Have you ever looked at a math problem that just literally breaks your brain? Well, welcome to this explainer. Today, we're going to unpack what is absolutely the most unintuitive mathematical paradox on the entire internet. We're taking a wild journey from a simple, faded notebook page all the way to the fundamental physics of the universe itself. So, let's get into it.
Let me start off by asking you a quick question. If you add up every single positive whole number from 1 all the way to infinity, what exact answer would you give me? I mean, right now, your intuition is probably screaming at you. You start at 1, you add 2, then 3, and you just keep going forever. The answer simply has to blow up into this massive, endlessly growing wall of infinity, right?
Well, what if I told you the answer isn't infinity at all? In fact, it's a fraction. And no, not just any fraction, but a negative fraction. -1/12. No way, right? This shocking, seemingly impossible mathematical assertion was actually proposed by a self-taught mathematical genius named Srinivasa Ramanujan. And today, we're going to see exactly how he created this illusion, and more importantly, why it is so much more than just a trick.
Section 1. Ramanujan's magic trick.
So this whole story actually kicks off back in 1913, when Ramanujan sent a letter to Cambridge University outlining this exact mind-bending idea. And the thing is, he knew exactly how crazy his math sounded. He actually wrote a warning to the famous mathematician G.H. Hardy right in that very letter, saying, "If I tell you this, you will at once point out to me the lunatic asylum." He playfully validated the exact total confusion you're probably feeling right now. He knew standard arithmetic was absolutely going to object to this. Okay, so the crucial point here is understanding the algebraic sleight of hand Ramanujan used to get his result. He basically broke it down into a really simple 5-step trick. First, he let the letter C equal our main sum, 1 plus 2 plus 3 plus 4, and so on. Second, he introduced a completely different alternating puzzle series called A, which flips between plus and minus. So 1 minus 2 plus 3 minus 4. Third, he took the original sum, C, and multiplied it by 4. Fourth, he subtracted that new 4C from the original C. And finally, step 5, he solved for the new value of A. But we really need to look closer at step 4, because honestly, that is where the real magic happens. This brilliant little move is the absolute core of his trick. When Ramanujan multiplied the series by 4, getting 4 plus 8 plus 12, he didn't just line the numbers up normally. Instead, he strategically shifted them so they sat perfectly underneath the even numbers of the original series. He basically just put a 0 under the odd numbers. And when you subtract 4C from C term by term, just think about the result. 1 minus 2 plus 3 minus 4 plus 5 minus 6. Does that sound familiar? That resulting series, which represents -3C, perfectly generates the alternating series A that we defined back in step 2. Now we just need to figure out what that alternating series actually equals. And thanks to standard calculus, specifically Taylor series expansions, mathematicians know for a fact that this alternating sequence actually stabilizes out to a value of exactly 1/4. So since we know our result from the subtraction was -3C, and we know that equals our alternating series, which stabilizes at 1/4, we just swap it in. -3C equals 1/4. You divide both sides by -3 and boom, it's literally just basic middle school division from there. See, our original infinite sum of all positive numbers equals -1/12. The seemingly impossible answer emerges right before our eyes. Section 2, the trap of infinity. All right, I have to pull the rug out from under you here. If you actually tried to pull this exact trick on a calculus exam, a standard math teacher is absolutely going to give you a 0. And the reason why is pretty straightforward. We just broke a core mathematical rule by totally ignoring the nature of a divergent series. A divergent series is a sequence that just goes on forever and continuously grows infinitely large without ever settling on a finite limit. Our simple sum of 1 plus 2 plus 3, that is a textbook divergent series. And this is exactly why the teacher would mark us wrong. See, normal arithmetic follows strict rules where fixed, finite values can be shifted and subtracted super easily. But infinity operations, they play by completely different rules. Because our series C grows infinitely large, writing C minus 4C is mathematically equivalent to writing infinity minus infinity, and that is an undefined indeterminate form. By changing the spacing of an infinite divergent series, exactly like Ramanujan did in his trick, you can accidentally prove it equals almost any number you want. It's a complete mathematical trap.
Section 3. Fixing the broken machine.
So was Ramanujan just playing a massive prank on everyone? Actually, no, not at all. We are going to transition from that flawed algebraic trick to the beautiful, rigorous calculus that actually proves Ramanujan's fraction holds a deep structural truth. Which brings up a really big question. How do mathematicians fix a broken machine? To understand the real math behind -1/12, we have to look at something called the Riemann Zeta Function. You can kind of think of this function as a machine. If you feed it positive numbers greater than 1, it works perfectly, gives you a clean, sensible answer. But if you try to feed it -1, the machine technically crashes. It spits out our exact infinite sum of 1 plus 2 plus 3 and just hits a total brick wall of infinity.
To solve this, mathematicians use a really cool concept that we can visualize with something called the fog bank metaphor. Imagine you are mapping a beautiful island, but a giant dark fog bank totally blocks your view of the west coast. You can't see it directly, but because the paths and terrain leading into the fog follow perfectly predictable, smooth curves, you can use advanced math to seamlessly extend those lines right through the fog. You can map out exactly where the hidden coast has to be, even if it's currently completely obscured. The rigorous mathematical term for this fog mapping is analytic continuation. It's a technique in complex analysis used to extend the domain of a well-behaved function directly into forbidden territory. When mathematicians extended the smooth, predictable rules of the zeta function into the forbidden territory of negative numbers, this rigorous method totally stripped away the infinite growth part of the series. And what did they find, sitting exactly where that hidden structural anchor should be? -1/12. Ramanujan's intuitive trick, even though it was algebraically flawed in its basic form, actually pointed to this profound, rigorously proven truth. Section 4. The universe's secret number. Now, you might be thinking to yourself that this is just some useless parlor game for mathematicians who have way too much time on their hands, but you'd be wrong. Because this seemingly absurd math trick has a staggering, real-world application. It literally connects Ramanujan's 1913 notebook directly to the fundamental fabric of the cosmos. In string theory, physicists track how microscopic strings vibrate in space. But when they try to calculate the total zero-point energy of these infinite harmonic oscillators, the equations hit infinite breakdowns. The math just completely blows up. So how do they fix it? Physicists actually substitute the infinite sum of whole numbers with Ramanujan's exact structural value of -1/12. And when they plug that in, a literal miracle happens. The infinities perfectly cancel out. The equations suddenly work cleanly. In fact, substituting -1/12 right here is precisely what proves that bosonic string theory must exist in exactly 26 dimensions of spacetime for our universe to even function. It is absolutely wild. So the really crucial point to take away from this explainer is that sometimes underneath endless chaotic growth, there is a hidden, beautiful reality just waiting to be discovered. The rules of normal arithmetic might break, sure, but a deeper structural truth remains. And that leaves us with one final provocative question to ponder. Is treating infinity this way a stroke of absolute genius, or is it total madness? Let that sit with you for a while. Thanks so much for joining me on this incredible mathematical journey, and keep looking for the hidden structures in the world around you.